Hello all, this is Dr. Karthika from Department of Biomedical Engineering, SNS College of Technology, Coimbatore. Today we are going to discuss about relationship between pixels in digital image processing. See here, I have listed some basic relationship between pixels, neighborhood, adjacency, connectivity, paths, regions and boundaries. See, basic relationship between pixels, we have to consider neighbors, diagonal neighbors. In neighbors we have 4 and 8. Here consider neighbors of pixel p at coordinates x, y. 4 neighbors of p, it is denoted by n4 of p. And here the elements are x minus 1y, x plus 1y, x comma y minus 1 and x comma y plus 1. 4 diagonal neighbors of p denoted by n d of p. Here we have the elements x minus 1, y minus 1, x plus 1, y plus 1, x plus 1, y minus 1 and x minus 1, y plus 1. 8 neighbors of p, it is denoted by n8 of p. n8 of p, it is equal to n4 of p union with n d of p. Okay, here adjacency, let V be the set of intensity values, and we have 4 adjacency and 8 adjacency. In 4 adjacency, 2 pixels P and Q with values from V are 4 adjacent if Q is in the set N4 of P. In 8 adjacency, 2 pixels P and Q with values from V are 8 adjacent if Q is in the set N8 of P. Okay. Here in M adjacency, 2 pixels P and Q with values from V are M adjacent if Q is in the set N4 of P or Q is in the set N D of P and the set N4 of P intersect with N4 of P, has no pixels whose values are from V. Okay. And next one is about path. A digital path or curve from pixel P with coordinates x0, y0 to pixel Q with coordinates xn, yn is a sequence of distinct pixels with coordinates x0, y0, x1, y1 up to xn, yn. Here xi, yi and xi minus 1, yi minus 1 are adjacent for 1 less than or equal to I less than or equal to en. Here n is the length of the path. If x0, y0 equal to xn, yn, then the path is called as closed path. For 4, 8 and m paths, based on the type of adjacency, we can define the paths. Okay, see here the examples of adjacency and path at v equal to 1, 2. Here the examples shows 8 adjacent and m adjacent. See here for 8 adjacent, the 8 path from 1, 3 to 3, 3. 1, 3, 1, 2, 2, 2, 3, 3 and second one is 1, 3, 2, 2 and 3, 3. For m adjacent, the m path from 1, 3 to 3, 3. 1, 3, 1, 2, 2, 2 and 3, 3. See here connected in S. Let S represents a subset of pixels in an image. 2 pixels P with coordinates x0, y0 and Q with coordinates xn, yn are said to be connected in S if there exists a path. Paths like x0, y0, x1, y1 up to xn, yn. Okay, let S represents a subset of pixels in an image. For every pixel P in S, the set of pixels in S that are connected to P is called a connected component of S. Okay. If S has only one connected component, then S is called a connected set. We call R a region of the image if R is a connected set. See, 2 regions Ra and Rj are said to be adjacent if their union forms a connected set. Regions that are not to be adjacent are said to be disjoint. See here, the examples are shown here. And here we have a MATLAB program for relationship between pixels. Here we have used IM read, IM show for image read and show. We have number of pixels and we have figures and image show. This is a simple sample program for relationship between pixels. And next one is about boundary or border and foreground and background. Okay, the boundary of a region R is the set of pixels in the region that have one or more neighbors that are not in R. Okay, all the points in R, U is called foreground. All the points in RUC is called background. Okay, see here I have shown some questions for your assessment. In the following arrangement of pixels or the two regions of one is adjacent, if 8 adjacency is used, what will be the adjacent? Consider region 1 and 2, and this is your second question. Consider the part 1 and part 2 if 4 adjacency is used. And question 3, in the following arrangement of pixels, the circled point is part of the boundary of the one valued pixel if 8 adjacency is used, true or false. Thank you.